In this video, we're going to use a graphing calculator to find the equation for a line of best fit. And then we're going to make a prediction and calculate a residual. So the concept of what is a residual is what's new in this video. So first we have a context where there's someone who is investigating how long a phone's battery is going to last depending on the brightness level. So we gather data, and for various brightness level settings, we have how many hours the phone has lasted. So if we're going to find the equation for the line of best fit on a graphing calculator, I'm going to hit the Stat button. And I'm going to hit Edit to get the data into the list editor. And then I'm going to type the X values into list 1 and the Y values into list 2. So I always do all the X values first as a whole column. Oops. Okay, and then I'm going to put the Y values in. And it's always worth your time just to quickly double check to make sure that you entered them correctly. The numbers all look good. So we had gotten to this place by stat edit. This is called the list editor. And now if I want to, instead of editing and typing in the numbers, if I want to calculate something like the line, I go to stat, and again, instead of edit, I'm going to go over to calc. So I hit the right arrow, and I choose linreg ax plus b. This stands for linear regression, having the calculator construct a linear model for this data. And it's going to have the form ax plus b, which is very similar to what you might be used to with mx plus b. So I run that. It's supposed to say list 1, list 2. If it doesn't, the lists are down here above the number keys. List 1 is above the 1 key, list 2 is above the 2 key, and so on. So list 1, list 2. You can leave all the settings and go down to calculate. And it tells me the slope and the y-intercept of my line. So looking at some of the questions we have here, I'm going to copy the screenshot that we just had. We have to find the equation for the line of best fit, and we're going to try to keep at least 4 decimals. Okay, so the equation for the line of best fit has the form y equals mx plus b, except your calculator is telling you ax plus b. So it's going to be y equals, and instead of a, I'm going to write what a is. And notice that it's negative 0.05, I'm going to say 77, that's 4 decimals, x plus 7.3121. So that's my equation for the line of best fit that the calculator gave me, because I have the slope, this is the slope, and this is the y-intercept. Okay, interpret the slope. Slope always has units. So if I go look, the units for y are hours, and the units for x are brightness level. So the slope is going to have units of hours per brightness. We'll say brightness level. So our slope is negative 0.0577. So it looks like we lose about 0.0577 hours for each brightness level setting on the phone, whatever that brightness level setting is. Okay, what does the equation predict for the number of hours the phone will last at a brightness level of 80? Now again, brightness level, if you go back up in the context, brightness level is x. And I can even see that it's labeled on the x-axis. So this is x equals 80. And it says, what does the equation predict for the number of hours? That's y. So really this is saying plug x equals 80 into your equation. So my equation is up here. So I'm going to plug x equals 80 in. Y equals negative 0.0577 times 80 plus 7.3121. And I get a prediction for the number of hours at a brightness level of 80. So I'm going to do that. Negative 0.0577 times 80 plus 7.3121. And I get 2.69, I'm going to round that up to 70, 2.70 hours. 2.70 hours. Okay, so that's my prediction. If the brightness level is set to 80, we predict the phone will last about 2.7 hours. Okay, well, if I go look, 80 hours, that's the prediction we just made. I have a data point that says the same thing. At 80 hours, it was actually 3.4, I'm sorry, 80 as a brightness level, it was actually 3.4 hours. And so that's what this question is here. It's pointing out that this was one of our points. When x is 80, notice that those match up. When x is 80, the actual value was 3.4. So that's kind of getting at the concept of a residual, is that when you look at a scatter plot of real world data and you were to kind of try to form a line of best fit, it might look something like this. The line is not perfect. Like the 80 hours, the value is up here. This is the actual point that we're looking at. It misses the line by a little bit. The difference between the actual point and the line, the fact that my line isn't perfect, that's called a residual. It's the difference between the actual and the predicted. So I'm going to write that out here. Residual is actual minus predicted. So again, in this problem we just did, the actual value for y is 3.4, and the predicted value I just got is 2.7. So if I go and subtract those, 3.4 minus 2.7, I get a residual of 0.7 hours. So that's what a residual is. 0.7 hours. It's the difference between the actual and the predicted, the fact that my prediction wasn't perfect. I have a data point that disagreed with my prediction.